In section 3.3, we're going to discuss increasing and decreasing functions. We want to let f be a function on an interval. We say that the function is increasing on the interval if for every value a less than b in that interval, f of a is less than f of b. So for any two values in this interval, the bigger one is going to have a larger output than the smaller one. Decreasing is exactly the opposite. If f is a function which is decreasing on the interval I, then for every two values a and b, where b is bigger than a, the output of a is bigger than the output of b. This is exactly what you think it should be. Let's look at a line, for instance. This line, as we move from left to right, is increasing. And what that means is that for every point on this line, for every two values of x, the x value, which is lower, is going to produce a lower output. If I plug in 1, I get the point 1, 1. If I plug in 2, I get the point 2, 3. So since 1 is a smaller output than 3, we are increasing. In other words, graphically, as you move left to right, you're always moving up. Now, this is an increasing function. Clearly, we can make this a decreasing function. This is y equals negative 0.5x minus 1. You can see as you move left to right on the graph, we're going down. Therefore, this is a decreasing function. Now, the term increasing and decreasing does not need to apply over the entire function. For instance, y equals x squared is decreasing from negative infinity up till you hit the point 0, 0, and then starts increasing as you move above 0. So it's decreasing from negative infinity up to 0, and then it's increasing from 0 all through infinity as you move to the right. So you start at 0, you move to the right, you're increasing. You start behind 0 and move towards 0, you're decreasing. So not every function is always increasing or always decreasing. And it's the goal of this class or this section to look at when a function is decreasing, when it's increasing, and determine some things about the function based on whether the function is increasing or decreasing. The idea of increasing and decreasing function should be fairly intuitive. Let's talk about the connection between increasing functions and derivatives. If you let f be a function on an interval I, f is increasing, means that for every b bigger than a, the output of b is bigger than the output of a. If we connect that to the mean value theorem, the mean value theorem says that there exists a C between A and B such that the derivative at value C is equal to the average rate of change. Now, that's so long as f is a continuous differentiable function. As long as f is a continuous and differentiable function, then the mean value theorem says we can do this. Notice that f is increasing for every a less than b in the interval. So if f is increasing on the entire interval, then we can plug in values of a and b in this interval no matter where they're at. And that means that we can kind of force these little sub-intervals to be really small, and we can force the derivative to be positive. Think about this. F of b is bigger than f of a. So when you subtract these two numbers in the numerator, you're going to get a positive number. B is bigger than A. So when you subtract these two numbers, you're going to get a positive number in the denominator. Therefore, the derivative is going to be a positive number divided by another positive number. So the derivative is going to have to be positive. Because we can do that for any B and any A we choose, it turns out that the derivative is going to be positive anytime we have an increasing function. Take a look at this. This leads to the test for increasing and decreasing functions. Let f be a continuous function on the closed interval from a to b and differentiable on the open interval from a to b. If the derivative is positive for any value in the open interval, then the function is increasing on the closed interval. If the derivative is negative for any value in the open interval, then the function is going to be decreasing on the closed interval. And if the derivative is 0 for every value in the open interval, then my function is going to be constant. This means positive derivatives correspond to where my function is increasing. Negative derivatives correspond to where my function is decreasing. And 0 corresponds to where my function is constant. This concept should make sense if we think about it in terms of the tangent line. Remember, the tangent line has slope, which is the first derivative. I've drawn the tangent line at various points here, and I can slide this. Notice that if we are on the function y equals x squared, or f of x equals x squared, from negative infinity up to 0, our tangent line has negative slope. It's pointing down. So the derivative ought to be negative. Once you hit the point 0, 0, the tangent line changes over to having a positive slope. Again, I'm just grabbing a point on the graph and I'm moving it around and showing you how the tangent line works. So negative slopes, and then we cross over to a positive slope when you're above 0. And this shows us that negative derivatives correspond to decreasing functions. Positive derivatives correspond to increasing functions. And obviously, if we had y equals a constant, then we'd have slope of 0. So constant functions mean slope is 0.